The first organic family that we're going to look at in detail is alcohols. In alcohols, we have a hydroxyl functional group. And in our general formulas, this is not true for alcohols, but all organic compounds. When you see this R here, it's referring to the non-polar hydrocarbon chain. And the R is just used to represent a generic chain, so it doesn't matter how long that is, how many carbons are in it, etc. In the hydroxyl group, we have a carbon atom directly bonded to a oxygen atom. So that's a polar bond, obviously. And also, because of the large difference in electronegativity, this functional group is also going to be capable of hydrogen bonding. When it comes to naming alcohols, the structure of alk, anol, that you seen last year will be helpful here. Just keep in mind, remember, whenever you see alk in the naming structure, that's where you put the prefix for the number of carbon atoms. And the suffix in this case for an alcohol is anol. So in a structure such as the one below, we can see we have got 3 carbon atoms. So we're going to have the prefix of prop, and our functional group is a hydroxyl, so it's going to be prop. Let's get rid of that. It's not propanol. Naming structure, prop from the hydrocarbon chain and anol from the hydroxyl functional group. We're not quite done with the naming because we need to identify which carbon within the chain the hydroxyl group is on. So we could number our carbons as 1, 2, 3, which we would notice we would have the hydroxyl on carbon number 3. But if we numbered it from the other end, 1, 2, 3, we can then see that it's on number 1. So that's the number we want to use. So we need to make sure we put that out the front. Always separating the number and the letter by a hyphen. It would also be appropriate to write prop 1 anol. Either way is acceptable. In alcohols, you'll often see more than one functional group or more than one hydroxyl group. So in this case, we've got 2 hydroxyl groups. You just use the prefixes for that previously discussed. So the prefix for 2 would be di, 3 would be tri, etc. So in this example here, we've got what we call a diol. Di meaning 2, the ol being functional groups. So if we just have a look at all the features to help us name this, so numbering our carbons, we can go 1, 2, 3, 4, or we could go 1, 2, 3, 4. If we're numbering from left to right, we have a hydroxyl on 2 and 3. If we're numbering from right to left, we have a hydroxyl on 2 and 3. So in this case, it doesn't matter which side we number from, we're going to get the same placement for our hydroxyls. So we can see from our parent chain there that we've got 4 carbon atoms, so we know that this is going to be a bute compound. We have got 2 hydroxyls, so we know it's a diol. But we want to include the and, so we go bute and diol. And our hydroxyls are on number 2, 3 hyphen. So we've got 2, 3 butanediol. Besides naming an alcohol or drawing the structure, you also need to be able to classify a particular alcohol as being primary, secondary, or tertiary. So within the structure, you will need to identify the hydroxyl group. And within a structure, you may have more than one hydroxyl group, and each hydroxyl may have a different classification. So if we have a look at each of these general structures here, we can see this is our hydroxyl group. Now, the first classification is a primary alcohol, primary or first degree alcohol. And if we have a look at the structure, once we've identified the hydroxyl group, you're looking at the carbon that is attached to it. And in this case, you can see it's only got one carbon chain coming off of that carbon attached to the hydroxyl group. So that's primary. If we have a look at our secondary alcohol structure here, secondary or second degree, we notice we've got two hydrocarbon chains coming off of the carbon that's attached to the hydroxyl. So that is our secondary alcohol. When we look at the structure for a tertiary alcohol, tertiary or third degree, we'll notice on the carbon that's attached to our hydroxyl group, we have got 3 hydrocarbon chains attached. So the key steps in classifying a hydroxyl group as primary, secondary or tertiary alcohol is to first identify the hydroxyl group, and next identify how many alkyl chains or hydrocarbon chains are coming off of the carbon which is directly attached to the hydroxyl group. Now, based on whether a structure includes a primary, secondary or tertiary alcohol, and will depend on how it behaves or reacts in certain situations. And one key process that you're going to be looking at is the oxidation of alcohols. So if you think back to your basic definitions of oxidation, you'll recall that one is the addition of oxygen or the removal of hydrogen. Now, if we have a look at our structures here, we notice that our primary alcohol has 2 hydrogens attached to that central carbon. Our secondary alcohol has 1 hydrogen attached to that central carbon, and our tertiary alcohol has no hydrogens. So when you're dealing with the oxidation of alcohols, it's probably a good way to think about it in terms of the loss of hydrogens from that central carbon there. So for example, a primary alcohol has 2 hydrogens, so it can be oxidized, and in each step of oxidation it's going to lose one of those hydrogens. Our secondary alcohol also has a hydrogen, so it can be oxidized, and in the process will lose that hydrogen. Our tertiary alcohol, however, has no hydrogens on that central carbon, so it is not possible to oxidize a tertiary alcohol. So when a hydroxyl group is oxidized, it turns into a carbonyl group. So let's have a look at what that looks like in a primary alcohol. So our first example here is of a primary alcohol. We can see we've got our hydroxyl attached to this carbon here, which is attached to only 1 hydrocarbon chain and has 2 hydrogens. So it's this hydroxyl group here that is going to be oxidized into a carbonyl, and in the process we're going to lose one of these hydrogens over here as well. So the new structure will look as such. So you'll see in our structure after oxidation we have a carbonyl here. Now it's in a terminal position, which means it's on the end of the structure, and what that makes this is an aldehyde. You'll notice within the structure we still have 1 hydrogen left bonded to that carbon, which means an aldehyde structure can actually be further oxidized. So in that further step of oxidation, you'll see that the functional group we now have is a carboxyl, giving us a carboxylic acid. Now if we have a look at our second example here, so this is a secondary alcohol, so we've got our hydroxyl group there. We can see that we have got an alkyl group on the left of the carbon and on the right, leaving one hydrogen on that central carbon. So it's the same process for this first step. So the oxidation of the hydroxyl group is going to give us a carbonyl. Now you'll notice in this situation our carbonyl is within the chain, so it's not in a terminal position. When we have a carbonyl placed like that, what we actually have is a ketone. We'll also notice in this situation there are no more hydrogens attached to that carbon, so it cannot undergo further oxidation. So our last structure here is a tertiary alcohol. We confirm that by having a look at our hydroxyl and the carbon attached to it. And then we can see we've got 1, 2, 3 alkyl groups coming off of that. Now something I want to point out here in this structure, I'm hoping that you can notice a mistake here. If we have a look at our carbon, there's 1, 2, 3, 4 bonds already coming off of it. So this is an example of an incorrect structure because that hydrogen should not be there. So I'm just wanting to point this out because I often see this in a lot of diagrams that students draw, thinking they always have to have hydrogens on these carbons. So this is how it should look, obviously without the big black dot there. But if you've got 4 bonds coming off of a carbon, there are no hydrogens. Now because of that, in this structure there are no hydrogens, so a tertiary alcohol is not going to undergo oxidation, so there's going to be no change in the structure. So just to recap, the important points to consider are firstly how to name and draw the structures of alcohols, using the anol suffix, also using the prefix of di, tri, tetra to identify the number of hydroxyl groups, and using the correct numbering conventions also. Beyond that, you need to be able to identify if a structure is primary, secondary or tertiary, and also name and draw the products of oxidation of a primary or secondary structure, and acknowledge that there will not be oxidation of a tertiary structure.